everyone. My name's Sarah Honak, Chair of the Webinar Committee, and welcome today to another one of our lunchtime webinar series, today on radon gas, risks, regulations and remediation. I'll just quickly whiz through the ground rules for you before we start. We will be recording and uploading this webinar to our YouTube channel. It'll be up there shortly afterwards, as long as the slides and any questions that we didn't manage to answer, they'll be on the website afterwards. We've got a Q&A box on the side of your screen. You can ask any questions during the talk there, and you can also like any questions that have been asked by other people. At the end, we'll ask as many as we've got time to ask, but any that we don't get a chance to ask will be given to the presenter later after the webinar, and she will answer them in her own time, and we'll pop them on the website along with the slides as well. Obviously, email to get your CPD points so you can register your attendance. And of course, we'd love to have your feedback. You'll get sent an online survey after the webinar, so please let us know what you think. Just like to point out that our 60th anniversary edition of Radiation Protection Today, our magazine, is available now. You can go to that website link there and you can have a read. We've got some really interesting articles, including one written by AI. And my favourite piece is one by Mystic Jim. Go check that out, it's the back of the magazine. Last but not least, just a plug for membership if you're not already a member. We've got loads and loads of benefits. Pop onto our website and you can see how you can join there. And finally, I'd just like to hand you over to SRP past president and AURPO immediate past president, Professor Peter Cole. Over to you, Pete.
Thanks, Sarah. It's my great pleasure today at this another webinar to introduce today's speaker. Rebecca Coates is head of radon projects at Propertico. She was the chair of the UK Radon Association between 2020 and 2022. She has managed national radon testing and mitigation programs for major UK clients. She's the UK's leading communicator on radon gas and has ensured that risks are understood by non-scientific people. She's been involved in policy consultations with the UK HSA, BLE and DCLG. And of course, she's a regular speaker at national and international conferences. So without further ado, I will hand over to Rebecca, who's going to tell us all about radon gas. Rebecca.
Great. Thanks, Pete. I'm just going to get my slides up. So we can start on radon. Right, here we go. So as Pete said this morning, we're going to talk about everything to do with radon. I know that a lot of people on the call will be RPAs or from a radiological protection background, but I know this webinar was opened up to anyone to register for as well. So whilst I'm going to skip through a lot of the sciencey bits to start with, I will still cover it, just to make sure that everyone's got the basic understanding of what radon is. Just a little bit about Propertico. We've been going for about 12 years now, and radon is all we do. It's our specialist business. We operate across the UK. And we're members of the UK Radon Association, which is an affiliate member of SRP, and also the European Radon Association as well. We do everything to do with radon, from consultancy, advice and training, through to testing for radon, designing mitigation systems, and then installing and maintaining those if you ever find you've got an issue. That's all I'm going to say about us and what we do. This is about what you need to know all about radon. I've split today's session into 3 sections roughly. Firstly, what is radon and why should I care? Sort of the basics. Second bit, when do I need to test for radon and how? And that includes all the sorts of legislation, reasons why someone might need to test, have a duty of care. And then finally, how do I reduce high radon levels? If you've done all this testing, you've found you've got an issue, what do you do about it? The good news is there are fairly simple things that can be done. So starting off with the basics, what is radon and why should I care? I should also say before I start today, I know that this is being run jointly with SRP and AURPO. Quite recently, there has been a focus on radon in education sector, schools, particularly colleges, universities. So throughout today's presentation, I am going to focus bits on schools. It applies to all workplaces, but I've got some specific case studies, some specific sections that are going to talk about the education sector as well. So what is radon? Why do I need to know? Radon is naturally occurring radiation. It's not being man-made, it's coming from the ground all around us, all around the world. There's uranium deposits in the ground. When those uranium deposits decay, they turn into radium. And then when radium decays, we get radon, which is a gas. Radium is a silvery solid metal substance. Radon is a gas, which means that radon can move much more readily through the ground and escape either into the atmosphere or into a building than its solid counterparts. So it's when radium decays into radon that we start getting issues. If radon comes out of the ground outside, it's not a problem. The problem is when it accumulates inside buildings and can build to a high concentration and then give rise to people in that building breathing this in, day out, and having an unacceptably high radiation dose. People in the past used to think radon was just naturally, passively infiltrating into the building, just was coming up and it just got there. It's actually an active process of the building itself drawing the gas in. We normally have lower air pressure in our buildings than we do in the ground and the soil around us, depending on what's happening with how we heat and ventilate the building or the weather outside. But usually we have negative pressure in the building. So that acts like a vacuum and it's actively drawing up the gas from the ground. The greater that pressure difference, the faster the rate at which it can be drawn in. So that's an important mechanism to remember for the end of the webinar when we talk about how do we deal with high levels of radon, and it's all to do with reversing that pressure relationship. Where do we find radon? Radon is everywhere in varying concentrations, everywhere in the world, certainly everywhere in the UK. This map is what we used to refer to since 2007 up until December last year, so almost a year ago now. This was the map that if you've looked at radon in the past, you may well have seen this map with different colours of yellow and brown on, indicating the probability of finding high levels of radon anywhere in the country. It's been produced by the UK Health Security Agency in conjunction with the British Geological Survey, where they combine their data on historical test results they've got and also the geologies, and then mapping that together to predict the areas most likely to have high levels of radon. Over the last few years, there's been a lot of work being going on behind the scenes with UKHSA and BGS, particularly with the geological mapping, to be a lot more precise on the areas and the specific geologies in different parts of the country. So this map was actually updated in December last year, December 2022. So don't want to look at this one anymore. This is now what it looks like. We've got a single map that includes Scotland and Northern Ireland now. They were previously on a different map. And you'll see that the colour scheme has changed slightly. It's still the darker the colour, the greater the probability, but we now have a different range of sort of creams and brown shades through to dark brown. The lightest colour is now cream on the map to indicate, and that's where it's a less than 1% probability of finding high levels of radon. That's been changed from white. There's a small distinction there. People previously thought white meant no radon. Doesn't mean that. It means there's a lower risk. It has been mapped. They do have data for it. It's not that it's blank and hasn't been shaded. It's just the lowest risk band. And then through the various shades through to the darkest brown areas are where it's been estimated that more than 30% of properties would have high levels of radon. You can access this map free of charge. The indicative version is available at ukradon.org, which is the government radon microsite and part of UKHSA. You can put in your postcode, any postcode, and get an indication as to what the radon concentrate, the probability of having high radon levels is like there. So I live in Bath, which is a high risk radon area. I live north of Bath in one of these dark brown areas up here. So I'm in one of the highest risk bands in the country. But as you can see, it does vary quite considerably, even just within a few miles. So it is important to check buildings to see whether you're in a radon affected area, and B, make sure you're checking the latest version. So if you've done any checks before, if you did it before December last year, you need to check again because the map may have changed. And it has changed. Just before the maps changed last year, we'd done a piece of work for a national client in the hospitality sector who had about 850 properties. They'd asked us to check, are they in designated radon affected areas? And an affected area is anywhere where the risk is more than 1%. So starting from the lightest brown colour on the map. We looked at about 850 of their addresses. We then had to redo this exercise once the new data set and the new map came out. These addresses were spread fairly evenly across the whole of the UK. So a good representative, indicative example of how things might have changed. And we found of those 850 addresses, we had 13% of the addresses that had gone from they weren't in an affected area, so they were in a less than 1% risk band, and now they were in an affected area, so anything from 1 to 3% risk and up. There was a bit of movement the other way. 2% moved out, so no longer were in affected areas. 5% had gone up at least one band, and 2% had gone down at least one band, and then the rest, 70-something%, was stayed the same. But it's those ones in the red circle top, that's 13% have now moved into an affected area band. It's important that the employer knows about those, and that if you have done any checks for any clients or your own workplace, that you check if you weren't previously in an affected area, that the new map hasn't now put you into an affected area. Special note on basements, those maps apply to above ground properties only. If you have a property with a basement, you are immediately at high risk of having high levels of radon in there, because it's a ground gas. A basement is in the ground, more surface area in contact with the ground through which the gas can permeate. You've usually got lower air pressure in a basement, less ventilation, so they are immediately at higher risk. So even if it's in a less than 1% risk area on the map, so the cream colour on the map, if it's got a basement, you have to proceed as if it was in a designated radon affected area. Why does it matter? Who cares if you've got radon in your building? Doesn't have a smell, so it's not going to make your house smell or your building smell bad. You can't taste it, you can't see it. You have no way of knowing how much radon's in a building unless you've done a test for it. The problem is it's radioactive particles that are continuing to decay, give off alpha radiation. If you're breathing that in, that is not good for our bodies, as we know, and unfortunately long-term exposure to radon is the second leading cause of lung cancer worldwide, and in the UK. It's responsible for over 1,100 deaths in the UK every year, which has been estimated based on epidemiological studies. And exposure to radon is the biggest radiation source that most people will get in their lifetime, and a lot of people have no idea that they're getting it. We go about our daily lives at work, at home, we don't think we might be being exposed to radiation. Yes, in the summer we put sun cream on because we know we've got the radiation from the sun, but we don't think about the air that we're breathing. Indoor air quality is becoming a much bigger issue globally, and radon is a part of that, and is a very important part that we need to be considering, particularly in light of how we now design and build our buildings to be more energy efficient. There's been various studies done over the years into the impact of energy saving design versus radon concentrations. There's one published in the BMJ. This is quite old now, this one. It was a modelling study, but based on the information at the time, they believed that the increased average indoor radon concentrations would go up by about 57%, which would have an additional number of deaths of, at peak, about another 270 deaths a year. And then the other study that was published in the Journal of International Indoor Air, that was a retrospective study looking at buildings that had been tested for radon. They were predominantly homes, I believe, that had been tested for radon 20, 30 years ago, and had actual test results. Then they went back to these same householders and did more testing, but asked them, what have you changed in your building in the interim? Have you had loft insulation? Have you had double glazing fitted? Have you had cavity wall insulation? All those sorts of things. And then they looked at the difference, and they found that all those things had put the average indoor radon concentration up, most particularly double glazing, which increased radon levels by an average of 67%. If you've got a very low radon level to start with, an increase of 67% still isn't going to put it into the area where you're concerned about. But if it's borderline or marginal, a 67% increase is quite significant. And these are the things that people are doing now with with buildings. We're designing new buildings like that, or importantly, we're going back and retrofitting these things to older buildings, and it does change the indoor air quality and the radon concentration. So we need to be aware of that. So how much radon is too much to have either at home or a workplace? How do we measure radon? What do we express it as? So as you probably know, in the UK, we measure radon in a unit called becquerels, which is expressed as per cubic metre of air, so BQM3. If you ever see anything on radon Googling and it starts talking about picocuries or PCI, picocuries per litre, and that's an American website that you're on, they measure radon in a different unit. So it's very confusing. I would advise you get off that website and find something that's talking about becquerels to get the accurate advice for where we are here. So we're talking about becquerels. Outside in the fresh air, the average radon concentration is said to be about 4 becquerels. So even outside, it's rarely 0. It might be, you know, if you test right up in the clouds somewhere, you'd probably get lower radon levels. But when it's coming out of the ground, you've got outside about 4 becquerels. The average home in the UK is said to have about 20 becquerels in, but that figure's been bandied around for as long as I've been in the industry. So I would actually think it's probably a bit more than that now, based on the previous slide and how we're designing and buildings now. And then we've got something called the action level. So for homes, the action level is 200 becquerels. And this is the point at which the government, via the UK Health Security Agency, advise that homeowners take action to reduce their radon concentration. We've also now got a target level for homes, which is half that level, 100 becquerels. And this was introduced in 2010. This concept following some more information that came from the World Health Organization in 2009, where they found that actually a large proportion of lung cancer deaths are probably occurring in the large amount of the population that's being exposed to moderate levels, say 150 becquerels. And actually we should be aiming to have our target level as low as possible, or our action level. At the time, it was decided in the UK, we don't want to change the action level, we'll keep that at 200, but we'll have this sort of 2-tier system, also to convey that there's no sort of linear safe line threshold of safe and unsafe. You're no safer at 199 becquerels than you are at 201. It's just a guidance level. And so the thought of the target level is, if you carry out any remedial works, always aim to get to below 100. Don't just say, oh great, I've got to 199 and job done. Or if you are if you get your first radon test results and your levels are between 100 and 200, if you're in a higher risk group for lung cancer, and that is if you're a smoker or an ex-smoker, you should strongly consider taking action when it's above 100. That is rolling out. More and more clients of ours say, actually, if there's that guidance out there, when it's above 100 becquerels as a target level, whoever it is in my family, I want to take action there. So I think in the future, it's probably likely that the action level might be reduced, maybe only to 150 becquerels. That would put it in line with the level they've got in the US and the equivalent in picocuries they use there. But at the moment, homes 200 becquerels as the action level and 100 as target level. They are only advisory unless it's a landlord and tenant situation, which I'll talk about later. But that's guidance. It's up to you if you want to do anything about it. In workplaces, though, there is legislation, which we'll come on to, and the action level for workplaces is 300 becquerels. These levels are all being expressed as annual averages. Radon levels fluctuate constantly. So we have higher levels in the winter, lower levels in the summer, almost twice as high in the middle of winter as the middle of summer, usually in a standard weather year in a standard property. And that's to do with changes in atmospheric pressure, soil gas pressure, and how we heat and ventilate our homes. The workplace action level is enforceable, and we'll talk about that slightly later. Another little bit I've put in here at the bottom, Public Health England, as they were, which is now the UK Health Security Agency, also have some guidance specifically for schools, where they say that the system for domestic protection should be applied to schools. So you'd be talking about an action level of 200 becquerels if it was a school building or a college or a university, rather than the workplace action level. And this is to do with it's young people spending time there, and they're spending a lot of time there and getting a lot of exposure potentially. That is just guidance though. It's a recommendation and it's not enforceable. How much radiation is that? We've got a lot of RPAs on the call today who can go away and do the dose calculations, and how many millisieverts of radon does this equate to, depending how much time you're spending. This is a method that I use when I'm talking to non-scientists, so building surveyors or housing providers or just general employers. How much radiation are we getting from radon, just breathing it in? So if you were to inhale or spend about 8 hours per day in a building with on average 200 becquerels of radon, the equivalent radiation dose that you would have in your lungs would be approximately equivalent to if you'd had 112 chest x-rays that year. And most people can understand that and understand that's not something that they would want to do. They wouldn't want to send their child to the hospital every third day for a chest x-ray, or their parents or whoever it might be. So that's the level of radiation we could be getting there, and that's just at the action level. I've got a chart here. When you get the slides, you'll be able to look at this if you do any radon testing. These are all approximate figures based on calculations. Once it gets above about 700 becquerels, it's the equivalent of radiation dose of a chest x-ray per person per 8-hour period you're there. The highest levels that we've ever dealt with as a company, we've had 2 where we've had 16,000 becquerels. One was a residential property in the southwest, one was a commercial property in a high-risk area with a basement in the Midlands. So radon concentrations can build up very high, but it's not, there's very few properties with the thousands and thousands of becquerels of radon. There are an awful lot with the moderate levels, and a lot of people being exposed to those levels. And so it's really important we don't just think about finding the highest ones. We need to find those, but we also need to find all the ones with the 200, 300 becquerels as well, of which there are a lot. If you want to think of the lung damage in terms of smoking as well, obviously that is the biggest cause of lung cancer still, and will be for some time. 8 hours per day spent in 200 becquerels of radon is approximately equivalent lung damage to if you'd smoked 5.5 cigarettes that day. If you have smoked those as well, though, and you're exposed to the radon radiation dose, there's a synergistic effect there, and the damage is more than just the sum of the two together. So the message is, if you're a smoker, stop smoking, and if you live in a high radon level, do something about your radon as well. And what's the biggest risk? Based on the statistics that we've got, you're more likely to be affected in your lifetime by radon-induced lung cancer than you are by carbon monoxide poisoning, or being in a road traffic accident, something like that. But these are all things that are immediate, devastating consequences, but happen immediately. So people hear about them. It's in the press if the family's overcome by fumes from a faulty boiler, something like that. Radon-induced lung cancer has a long latency period. You need to be exposed usually for a number of years for it to become apparent. Therefore, it doesn't get the attention that possibly it deserves. So a lot of what I do is trying to raise awareness and make sure people understand this, so it doesn't become the next asbestos when people are saying further down the line, why did no one tell us? Why do we not know more about this? So having said that, whose responsibility is it to do anything about it? It's coming from the ground. It's always been there. Whose fault is it? Is there? Can we blame anyone? Who has to do something? Well, there's different responsibilities depending what sort of building we're talking about and whether you're a homeowner, an employer or a landlord. Before I go through those, I'm going to talk about how we test for radon, because a lot of the responsibility is testing for it and when you have to do that. So let's understand how we do a test for radon. There are various ways, but the most common and a very accurate way of doing it in the UK still, and most cost effective, is to use a passive detector. So this is a radon detector. It's a small dome of plastic, and inside there is a plastic lens made of highly sensitive plastic. That gets left in place for a period usually of 3 months in a building. There's no on-off switches or flashing lights or anything like that on it. It's completely passive. When it's left in place in a designated place in the building, it's left there for 3 months. The air naturally passes through the detector. After 3 months, goes back to the lab, they open it up, they look at the plastic inside, they process it, they put it under a very powerful microscope, and effectively what they're doing is counting the dots. Radiation will make, we call it a track etch detector, so it makes little indentations on that plastic lens inside. And the more dots, the higher the level of radon it's been exposed to over that test period. It's recommended that you test for 3 months. because radon levels are fluctuating constantly. And based on a 3-month result, we can then apply a seasonal correction factor to take account of the time of year you tested and give you your annual average result. We can also, though, do a snapshot test. We call it a screening test in as little as 10 days. So we don't do anything less than 10 days. But a 10 days and upwards, we can give you a result. It will be an indicative result with caveats in that it may not be representative of your long-term average, but usually they will give an indication as to if you did have very high levels, it will give an indication that you've got an issue, or if it's very, very low, particularly if you test in the winter and it's low, you can be fairly confident that you don't have an issue. But we do always recommend that you follow up with a long-term test when possible. They're usually used in conveyancing when someone's trying to buy a house and they want to know, is it likely to have a radon problem or not? This is the typical, as I was talking about earlier, seasonal variation in radon concentrations. So we're now coming into the time of year when radon levels are increasing and are at their highest. The winter months are a very good time to do your testing. You can test at any time of the year, but if you test over the winter, you know pretty much that you're getting the worst case results. And then any seasonal correction factor is estimating how much lower than that it would be as an average. Whereas if you test in the summer, it's the other way round. And it may be that your results actually, you've got more variation than the average building and you might have higher levels. But testing over winter is a brilliant time to do it. How many detectors do you need? Where do you place them? So if you think about a standard home residential property, normally you would use 2 detectors, one in a ground floor living room and one in a bedroom at first floor, or if it's a bungalow, put them both. You still have 2 because it's over a larger footprint. And they sit there for 3 months. In a workplace, it depends how many you need, and it depends on the overall size of the building. And the layout. Is it open plan? Is it lots of individual little offices? How many stories is it on? So you need to always test ground floor. Usually it works out, if it's a sort of standard office block, something like that, about one in every 3 ground floor rooms. We always also place some detectors at first floor as well. We don't usually go above first floor, but we do a small representative sample of detectors at first floor. And if you've got a basement, you should monitor each individual area. The basement should be monitored if it's occupied for more than 50 hours a week, and that is regardless of whether it's in a radon affected area or not. So it doesn't matter what colour it is on the map. We can calculate all this. So clients usually send me floor plans of their buildings and say, how many detectors do we need? And we look at those, mark them on, and then let them know where to place them. If we think about schools, what does that look like? How many detectors? So in a primary school, you might have about 14 radon detectors placed. A secondary school, probably about 60. An independent school with boarding houses and lots of different buildings to it might be about 200 detectors across campus. We've done some universities where we might have upwards of 400, 500 detectors. It really does depend on how big the site is. And this is also roughly what it would look like on a floor plan there. If you send me a floor plan of your building, that's the sort of thing I do look at and say, okay, this is the rooms where I would put some detectors and how many you need. Practical points. So we do offer a place and collect service. So for clients, we go out and put detectors in and we pick them up after 3 months, or sometimes we can post them. If you've got estates teams, departments who are happy to do it, they can just be sent by post and returned by post for analysis as well. If you're doing that and doing it yourself, we advise the following: make sure that you secure the detectors. They've all got a loop on the top. We recommend putting a cable tie through, because 3 months is a long time to expect something to still be there when you come back to look for it. They've all got an individual serial number on them. So whether you use our detectors or detectors from someone else, they'll all have some sort of serial number identifier. Make sure you log exactly where that was, which room it was, which building it was in, and the dates that you put it in and the date that you took it out. It doesn't matter if you've been told it's a 3-month test and after 4 months you suddenly realise, oh help, we haven't sent these back. It doesn't matter. Our detectors, as long as they're back within, we say 11 months of them being supplied, so that we know that it's within 12 months of the detector being manufactured, that's fine, as long as they've been stored correctly and they've been left in place. If you did collect them after 3 months and then they got forgotten in your desk drawer for 3 months, that's no good. We can't then analyse that. But if they've been in situ, it doesn't matter if it goes beyond 3 months, and just log the actual date, so the calculation of counting the dots can be spread across the actual test period. And make sure they come back for analysis promptly, within a day or two of them, ideally the same day, of being removed from the test location. There are now a range of digital monitors out there as well. So passive testing is the cheapest way and cost effective over large property portfolios. We charge £16.50 as our standard start price for each one of those detectors, including the lab analysis, and that's if you're just, you know, a householder buying one. If you're buying multiples, then that cost comes down. We've got digital monitors though that are useful in different scenarios for people who've want to do ongoing monitoring. They want to have their own monitor that they can maybe move around, or they've had some remedial works and they want to have this as a way of checking that the mitigation system is still working. So the one on the left's been around for quite a while now. It's called the Canary, or they rebranded it, I think, recently, Corentium now. It's a battery operated monitor, pretty good. It will take about a week before you can place any reliance on the results because it's doing all sorts of internal calibration and calculations. But after that point, it will give you a 1-day average, a 7-day average, and long term up to a year average on the screen as a rolling average. That is all in arrears, so the sort of 1-day average is actually what the previous 24 hours average was, just with how it calculates it. They're fairly inexpensive, battery operated. You can reset it if you want to move it to a different building, and will give you an indication. The one on the right here is a newer one called the EcoCube, and it's more of a smart device. So there's no readings on the actual device itself, and this one does need a power supply. It's just got a little LED, which will be red or green, depending on what your level is. And you can set the threshold at which it changes. And this one hooks up to an app, which looks like this. And as you can see, you get your average reading on there, or your current reading at the moment on the screen. And then you get a graphical output as well, showing the fluctuations. And that can be over a day or a week, a month or a year. This is really useful. So this one is actually at my house. So nice. I've got nice low levels at the moment. Well, this was a couple of weeks ago. It was 11. It's going up now. We're getting into the winter weather's coming and the storms. So yeah, I think I'm on about 20 today. But it shows the fluctuations, and it's really interesting. This, if you do any remedial works and you want to see what impact has that had, or if you change the ventilation, what impact has that had, and you can see this. Or do we have high radon levels overnight when there's no one in the building, and they go down in the day when we start ventilating, or our ventilation systems kick in? So it can be really useful for drilling down and doing a bit more in-depth analysis of how radon levels fluctuate in a building. And they're relatively new, but they are available from us to buy those. So that's how we test for radon. Who has to test for it? When do you have to do it? What does the law say? So very quickly, for your own interest, homeowners, it's up to you if you want to test. If you do test, it's up to you, and you find you've got high levels, it's up to you if you want to do anything about it. And the only time that it does potentially become a sticking point is in conveyancing. If you're trying to sell your house, it does come up on the inquiries before contract, and the search is the property in a radon affected area, yes or no? And then if it says yes, people often turn to Google and then get worried about it, and then they want to start testing. So I would always recommend, if you're in a radon affected area, or if you've got a basement, you're going to put your house on the market, do a radon test first. The probability always is that you won't have an issue, but then you've got a test certificate that you can show to say, yeah, it's fine, and move on with the sale. For residential landlords, you do have to do radon testing. Comes under the Housing Act, refers you to the Housing Health and Safety Rating System, which rates all hazards, things like electrical hazards and fire hazards. Mold, dampness is obviously a big one at the moment. Radon is in there as well. It rates hazards into different bands, with band A being the most serious. And there's different calculations you do to work out how prevalent your hazard is in the building. Once radon levels get to about 200 becquerels, so at the action level, it's a band C hazard. Over 800 is band A. Anything in bands A to C, A, B and C, is called a category 1 hazard, and all category 1 hazards should be dealt with by the local authority. The bit where it tells you you actually have to test is in the guidance document behind HHSOS, where it says what you have to do. So firstly, I'll just correct this statement that says there's little or if any need to consider radon as a hazard unless the dwelling's in an affected area. I would say unless it has a basement, in which case, yes, there is evidence that you do need to consider it. And then it says if it's in an affected area, the only way to determine whether or not there's a threat to health is by measurement. And the bit before that says as radon levels can vary widely between apparently identical dwellings, you need to test. So we have had instances where we've done testing for housing providers. They've got a row of bungalows or even a terrace. Most of them have very low levels, and there might be one somewhere in that row that has got high levels. And that could be to do with the immediate geology under that building that we can't see. Is there a fissure there or something that's causing the gas to come there? Or is it to do with lifestyle and how people heat and ventilate their homes? So you can't just pick and choose a sample to test. You can start by that if you've got a big portfolio and you need to start somehow, but ultimately each property does need its own test to complete your risk assessment. And it also now comes under this legislation as well, which catches all of those hazards. So if it's above 200 becquerels and it's a tenanted property, so this would include things like halls of residence in university accommodation, you need to do mitigation. You need to reduce the radon concentration. If it's above the target level, so between 100 and 199, that would put it as the next category down, category 2 hazard. It's something that you should consider doing. And if you happen to have a visit from environmental health, looking at things, they might say, what have you decided to do? Or you'd have to justify why you weren't doing something. And it could be you say, oh, it's only occupied for however many weeks a year and only for this number of hours a day. So if it was something like university accommodation. Important bit here, employers. Who has to do anything for radon and when? So under Health and Safety at Work Act, Management Health and Safety at Work regs, you have to identify and assess hazards that might be posed to staff. Radon is a hazard, so every single workplace in the UK should have a radon risk assessment, just like they have the fire risk assessment and everything else. There should be a radon risk assessment, but I would bet that a very small percentage of employers in the country have actually done that. It can be very basic. It can look like this. Put your address on, you check the map. Are we in a radon affected area? Yes or no? Do we have a basement? Yes or no? Based on those answers, we think, yes, we do have a risk of having high levels of radon, so we're going to do testing. Or no, we're in a less than 1% risk area. We don't have a basement. We're based on the 4th floor, something like that. That could be your risk assessment finished, but you do need to do it and you need to document it. And the first step is always check the maps. If you have identified that you do need to do testing, so you're in anywhere area on the map that's not cream, or you've got a basement, or both, then you need to do radon testing. So that's all below ground workplaces in the UK where it's occupied for 50 hours or more a year, and all workplaces in radon affected areas. You do your radon testing, we can advise how many detectors you need, you get your results back. If it's less than 300 becquerels as an annual average, then that's fine. You don't have to do any further work. You will be advised to repeat the testing and repeat your risk assessment at some point in the future, and it's not more than 10 years. So it has to be at least once every 10 years. Depends on what the radon concentration was, how frequently you need to retest. And we have different bands that we advise. So we might say, if it's over such and such, do it every 5 years. If it's over so much, do it every 2 years. But you don't necessarily have to do it all. It's certainly not something you do every year. If your results come back though, and you've got any areas that are over 300 becquerels as an annual average, then IRR 17 applies. The Ionising Radiation Regulations 2017, which I'm sure most of you on the call are very familiar with. These apply to anyone who does work with ionising radiation. So usually we think of things like people working in hospital X-ray departments or people at nuclear power stations, something like that. If you've got students and staff in a school or the bar staff in the students' union bar, something like that, or whatever it might be, an office, a shop, anything like that, if you've got high levels of radon there, those people are working in an environment with ionising radiation, therefore IRR 17 applies, and all of the criteria that you have to do under IRR 17 applies. So what are your obligations? First, the employer needs to appoint a radiation protection advisor. to advise them on the immediate steps they need to take to limit exposure. And that could be doing some calculations on occupancy and the radon concentrations to calculate the dose to see whether long term there is an issue. And what is the dose that people are receiving? If it's an area that someone only occupies for 1 hour a week, then whatever the radon level, it might be fine. They can manage that just by managing the access, managing exposure by limiting access. But that does need to be a documented process. It needs to be a risk assessment. It needs to be formal. You probably need to have something like a sign-in, sign-out sheet in the room, so you can evidence that you know what exposure people are receiving. Typically, though, employers don't want to do that. They don't want to have to be remembering to do that, keep all of those records. So they usually approach us, people like us, and say, what can we do to reduce the radon level? That's where we come in. We can carry out remedial works. It's really important that you retest afterwards to demonstrate how much the radon level's fallen. And then if it has fallen sufficiently, IRR 17 no longer applies. Another step that I've missed off this slide, which is very important, is that you must notify HSE. So it's just the notification level, the free notification level. There's a special section under there. It's all done online now for if you found radon levels above 300 becquerels as an annual average, to notify them. There's different bands. I think it's if it's above 300, or is it above 600, or is it above 1,000. You only have to notify once as the employer, regardless of how many sites you have. And you would only ever have to re-notify if anything changed. So let's say you tested one of your sites and you found 400 becquerels, so you tick the I've got up to 600 becquerels box. If you then tested somewhere else and you found a higher radon level, you might have to re-notify and click a higher number in the multiple choice answers. But once that's done, it's logged with HSE. They don't tend to follow up on that unless you've got very high levels currently, but things may be changing. But it's important that you've done that, because if you did get an inspection and you've missed that step out, they will not be happy. And one of the other obligations is you're meant to inform employees that you've found high radon levels and what you're doing about it, and advise or recommend that they might wish to test their homes if they're living in the local area. They've potentially been receiving radiation exposure at work. You're going to deal with that, but if they're living locally, they might also have an issue, so just alert them that they might like to test their homes. So I've got a flow chart there. I've got a pack that could accompany this webinar for employers guidance, so I'll send that out via Charlene at the end as well, so this is all included in there. I've got a few slides here that I took from a presentation that James Taylor of HSE gave at the National Radon Forum at UKHSA last November, because I think this highlights the position and why radon is creeping up certain people's agenda at the moment. So at that stage, James Taylor presented this, and he said HSE had discovered a school in Bath with high radon levels, and because it was so high and because they were so concerned about this, they've never done this before with radon, took a proactive approach, and they wrote to every school in Bath and North East Somerset, which was about 60 something, and said, where's your radon risk assessment? Send me your test results. If you haven't got one, haven't done anything, this was about November time, you've got until March to send me the results. I'll be in touch. So we got very busy. I live in Bath, and it's where the company started, with lots of phone calls from lots of schools. We had already done some work for the local authority here a few years ago, but of course now a lot of schools have academised, so they are all run by multi-academy trusts or independently. So anyway, HSE found out about who these schools were who had done the results, so not less than half had actually done the radon testing. Others had never done anything. They all were tested in the end. HSE made sure of it and kept following up until they were done. And in the end, it says here 9 schools. I believe there was one more, 10 of those 66, plus the one that originally was found to have an issue, were found to have high radon levels above 300 becquerels. That unless HSE had written to them and said, do you know you're meant to have done a radon test, radon risk assessment, they would still have those levels today. And we worked with a lot of those schools to reduce the radon concentrations, and are now doing ongoing monitoring with those. HC said their current policy was to carry out reactive work only, except if the levels were above 1,000 when you notified, but they are now reviewing this. So that may change. They might start following up with everyone who notifies. This wasn't in James's slides, but he said this, and I thought these figures were fairly remarkable. So I wrote it all down and thought this is something good content that people will make people think, why are we not doing more about radon? So he said roughly, and I've checked, sort of fact checked this as much as I can, roughly there's about 32,000 schools in the UK, and this is just schools, not talking about universities here. 32,000 schools in the UK. About 10% of those are in radon affected areas according to the latest maps. Let's say conservatively an average of 200 pupils per school, which is a conservative figure. I know we've got very large secondary schools now with much more than that, but let's say 200 pupils per school. And let's say based on the Bath results, and as you saw the map at the start when I put up of Bath, there are different categories of the radon affected areas in Bath and North East Somerset, some very highest risk, some lowest risk. But let's say 17% of all those schools, once we've drilled that down, would have high radon levels. That means that today there's probably more than 100,000 school children sat at school breathing in, inhaling radon, radiation at unacceptably high levels, above 300 becquerels. 100,000 children nationally, plus the teachers and all the other school staff, plus all the children who've already been through that school and have left, but they've received 6, 7, 8 years of radiation exposure whilst they were there. That's a huge amount of people being exposed to huge amounts of radiation very early on in their life, and you can't undo that radiation damage. Once it's done, it's there, and then it's going to be built on throughout the rest of their lives. So this is not acceptable. This is why HSE are now really bringing this to the forefront. And a few months ago, so it was in July, just before the summer holidays, they took the original school that kicked off that project in Bath to court, and they prosecuted them, and they were successful. This is the first prosecution there's ever been of an employer for anything to do with radon. It was a private school, a boarding school in Bath. They were fined £50,000, which was well down on the start point of where the fine started, but because they've worked really hard to do everything they were meant to do since then, and because it's a school, the judge did find mitigating circumstances to bring the fine down. They also had about £20,000 of costs they had to pay as well, though. And what had happened here was the school had done testing, then they'd done some remedial work, and then it had all been forgotten about, and they hadn't maintained the systems. An HSE inspector came round, they said, oh, what are you doing about radon? And then they scrabbled around. And it was found that they had high radon levels again, and it was because that they'd known about it in the past, and then they'd taken their eye off the ball. That HSE here were particularly cross about it, I believe. So yeah, they were prosecuted, and this is the first prosecution that's been for radon, I believe, in the whole of Europe. I don't know of any other cases. There might have been some that over the pond in the States. There's been tried to be prosecutions, and this is because people were exposed to the radiation. It's not because anyone has lung cancer or anyone's died. That might happen in the future, we hope not, but it's because they knew about there was a risk and they didn't manage it. And anyway, these were the sorts of headlines that came out in the next few days about a school, which no one wants to be reading that. No one wants to read that about their workplace or where their children go to school, anything like that. So we need more compliance. At the moment, I don't think employers are not complying deliberately. I think they just don't know that they're meant to do it. So we need to make sure, and in your professional capacities, that you're advising all of your clients this is something they need to do. So they do your testing. What happens if you find high radon levels? How do you reduce the concentration? Good news is it's relatively simple. It doesn't involve ripping up floorboards or, knocking down buildings. It's mainly done with changing the air pressure ratio between the ground and the building. So firstly, when we come to do a design survey, we may well do some grab sampling. This is some kit that takes a 6-minute radon sample. It's counting the alpha particles. It we would never use this to say whether you had a problem or not to start with, because if we came back tomorrow, or if you opened all the windows, something, we might get a completely different result. We just use this for painting a picture, to fill in some of the blanks. If we've tested one in every 3 rooms, we'll test the one first where we knew we had a problem or what the level was, and then use that to benchmark and say, okay, are the other rooms roughly the same? Are they higher? Are they lower? Do we have a really high point somewhere that's our obvious point of intrusion? Is there a hotspot somewhere? So it's to build a pattern of results to help guide the mitigation design, not to do an instant risk assessment to say, do you have radon problem or not? Because that would not be the correct use for this equipment. And then we say, right, which of these options would be best? So usually it's a radon sump system, which is creating a negative pressure beneath the building, or it's a positive pressure, sometimes called positive input ventilation system, which is very slightly increasing the air pressure inside the building. So just looking at sumps first, this is what we do. Usually we come from outside the building, dig down, drill under the building, excavate a small amount of the fill, which becomes a low point of pressure. So the gas is automatically drawn towards that low point of pressure. We then further enhance that and make sure the gas is going where we want it to by putting in some pipe work with an inline fan that runs constantly to exhaust the gas from the sump, and usually safely above the eaves level. It needs to be well away from any opening doors or windows. So usually that's at the roof line. This is what it looks like when we're installing it. So we might lift up some flagstones, dig up a bit of tarmac or a bit of flower bed, something, and then it's with diamond drilling, drilling through the wall to underneath the building. And then we put the pipe work in. Something like this takes less than a day usually to do one system. The only time we need to go in the building is to do the electrics, so there's not really any disruption for the building users. It's a bit noisy when we're doing the drilling, so if it was a workplace we would try and do it out of hours. Certainly in a school we would do it at a weekend or in a holiday period. And then this is what it looks like. The fans and pipework can all be black or white, so it's not hugely visually obtrusive now, and they're pretty neat systems. Sometimes we have to put the fans higher, so these are both schools. Usually the fan goes as low as possible because then you get less noise from the system, and any noise you do get, it won't be the fan, or certainly not with the fans that we use, which are designed for this. They're radon-away fans that we import from the States because they're the best radon fans we can find. The fans are very quiet. Any noise is the wind rush or the air movement coming from the sump being drawn up by the fan through the pipework. So the shorter that distance is between the sump and the bottom of the fan, the less chance there is for any noise. Something like a school though, or if it was on a trading estate where there might be vandalism issues, or a school where you don't want children fiddling with electrical equipment, we have to put the fans up higher. Very occasionally we have to do internal radon sumps. This is a school where we call the external ones mini sumps usually. We tried with mini sumps across this campus of this school. Elsewhere in the school they'd work perfectly. In this particular block, something to do with the floor construction, which no one could have told us before we did the work, they had very little effect, if any, on the radon levels in this corridor. And this block, they had up to about 800 becquerels in classrooms on either side of this corridor. So we said the only thing we're going to have to do is put in these full sump systems, a series of them down the corridor to get more centrally, and then they were connected to a single fan, a larger fan, but a single one outside at the end of the corridor and the end here. We also then introduced positive pressure into the corridor as well, and the radon levels came right down. We very rarely have to do that. That was done in the school holiday period, so all the floor could be relayed afterwards. But I could probably count on 2 hands the number of systems that we've had to do internally like that in 12 years of the business. Usually it's much less disruptive when we go outside. Sometimes you need to do more than one sump system depending on the size of the building. So this was a large call centre and they actually had 2 on this side, 2 on the other side. And again, the fans up high because it was a trading estate. Sumps are really effective. Can't really say on average they'll bring it down from X to Y. We don't know until we do it, but they are effective and we install a lot of them every year. The other option is positive pressurization. which is slightly increasing the air pressure in the building, so you're inhibiting and reducing that advection process of the gas being drawn inside. You'll never stop it entirely, so we don't use this if your levels are very high. If your concentrations are above about 350 becquerels, we wouldn't recommend trying positive pressure unless you do it in combination with a sump. It can enhance the effect of the sump. They work very well together, they complement each other, but if you've got moderate radon levels, then these units are really good. In a domestic setting, you can put it in the loft. Up here, it draws extra air in, filters it, warms it slightly, diffuses it through a diffuser on the landing ceiling. There are also wall-mounted versions available. So that's the loft-mounted one. Different manufacturers have different filters. They all look slightly different. This is a wall-mounted one, so we've drilled through the wall behind there with a louvered vent, and that's where it's drawing the air in. That's in a classroom, that one. And they're really effective. This is a high-capacity one. If we need to duct the a long way through a building, you might need something a bit beefier than this one. That particular one that I showed you there was in a bank basement. We do a lot of work in the banking industry where the vaults and the strong rooms tend to have very high radon levels because the way they're built and designed, and they're shut up, so the air pressure in there, they tend to get very high levels of radon building up. And in those ones, we can successfully reduce even this is 5,500 becquerels with just positive pressurization, because just putting some extra air in there sorts it out. And this particular bank had high levels throughout the basement, so it had a combination of sumps and positive pressure down there. I'm very quickly going to talk about new builds because I want to leave some time for questions, and I know time's getting on. New builds under the building regs, there's this guidance, which was again new out. This was new out this summer or updated. BR 211 tells you what you should do and where. It's been in existence since about 1991-92, so any buildings built before then won't have any radon protection in at all. Anything since then, it would depend on what the guidance was at the time and what the maps showed at the time and where different things were required. There's three categories of protection, radon protection under BR 211. The first one is no protection. You don't have to put anything in your new building to protect from radon. The second one is basic protection, which is you need a gas-proof membrane. And the third one is full protection, which is you need the gas-proof membrane and the facility to carry out some active mitigation in future if required. And that would be either a sump system, we call it a standby sump, that's built in and capped off, ready to be activated with a fan if needed, or a suspended floor, ventilated block and beam floor that you could ventilate mechanically if required. Now, you would think logically that I said before, anything above 1% risk is classified as a radon affected area. Anything above 1% risk, you have to do radon testing if you're an employer. So you'd think, once if you're in an area where it's 1% risk or higher, that's where you need to start putting radon protection in. Sadly, not in the UK. Sadly, not in England. In England, currently, the building regulations do not require you to put in radon protection, basic radon protection, until you're in the 3 to 5% risk category or more on those maps. So there's huge parts of the country shaded in the lightest brown colour, 1 to 3% risk, where it's a known radon affected area. Someone can put up a new building with no radon protection at all. That is not the case in Scotland, and I believe in Wales. I'd have to check Wales, but I know in Scotland they need radon protection once it gets to 1 to 3%. But the building regulations for England is it only comes in when it's 3 to 5%. I would say that's fairly ridiculous, and if you are commissioning a new building to be built, you know about on your site, you know you're in a radon affected area. If you know you're in the 1 to 3% band, just ask for a radon barrier to be put in when it's built. Minimal extra cost, and much easier and cheaper to do it then, usually, than doing the remedial work. And then once you get up to the darker colours on the map, you need the full protection. This is what basic protection looks like. It's a membrane, it's an upgraded damp-proof membrane, effectively a thicker membrane. It needs to be heat sealed, jointed, it needs to be perfect if it's going to work. If it looks like this, it's not going to be gas-proof. Gases move through even the smallest defects, and particularly when you've got that pressure difference. Very quick science experiment here. Next time you have a takeaway coffee cup, have a look at the lid. You have a big hole to drink the liquid out of, and then 1 or sometimes 2 tiny pinpricks on the top. you might mistakenly think, oh, it's to let the steam out. No, the point of those is so the cup does not depressurize when you drink your coffee. When you take out the same volume of liquid out of the big hole, you drink that, the compensating amount of air goes back in through those 1 or 2 tiny pinpricks. So there's the same volume moving between big hole and tiny hole. It's just gas needs a much smaller hole to get through than liquid does for the same volume. So if you think about a gas barrier, if it's got a slight tear in it, you might get away with it. If it was a damp-proof barrier, you might get away with it. Might not be any visible damp coming through. It's got a little tear in it, a lot of gas could come through once you've got that advection process causing the suction effect on top of that. And the trouble with when it's gas, if it's radon, you can't see it or smell it. So you don't know. If you had a damp patch, you'd know there was an issue with your barrier. With the gas, you don't know. So it's really important that buildings are tested, new buildings, on construction. If you need to do full protection, it's this sort of thing, putting in the sump boxes like I showed you down that corridor, but then capping them off outside, ready to be used if needed. Couple of case studies, then I'll open up for questions. So here's just a multi-academy trust where we did some testing across their schools. Across their almost 30 schools, they found they had 3 that needed mitigation. You can see this school's got a couple of sumps on the end here. This was a new block, relatively new, but had very high levels in it. This was the floor plan of another one of their schools sites, where just to show why we use the number of detectors that we do, I've marked on the results here, all the green ones are low, under 100 becquerels. There's a couple of orange ones which are sort of in that moderate, above the residential action level, but not above the 300 becquerels workplace action level. But then look, we start seeing things like this in red here, 2,657 becquerels in, this is labelled office here in this part of the site. And then we've got high levels in this building, including a high-ish one, 240 at first floor level. And then this little room in the middle here, rooms around it had 71 becquerels. This one had 2,084 becquerels in it. So that's why we test the number of rooms we do and the locations that we do, to make sure we're not missing things like this. Deal with this through a combination of sumps, and then you can see there's a positive pressure system here that's being ducted into the problematic room here. Was an internal office that had no ventilation at all, and so we ducted it across that nursery room over there. Another school group had some older buildings, old church school buildings. We found high levels in the old building and then in more recent extensions as well. Dealt with that again, combination of sumps and positive pressure. I want to have time for some questions. I know we're just after 1 o'clock. I hope we've got time for a few now. Thank you for listening.